Alright, so we're going to be moving on with Chapter 3, the organic molecule of life. So today, basically what we're going to discuss is the different organic molecules of life, and we're going to kind of focus on carbohydrates, lipids, protein, and nucleic acid. So first of all, let's start with what are organic molecules. So typically when we think of organic, we tend to think of more of like in terms of the food we eat, right? Is something organic? Does it have pesticides in it or not? Or is our beef, grass-fed? Are they treated with hormones? That's kind of what we typically think of when we think of organic molecules. But on the biology and the chemistry term, when we're talking about organic molecule, we actually mean molecules that are made of carbon and hydrogen. And so that's the backbone, right? So you can see in all these pictures, these are different organic molecules. And they all have, so we can see that all these molecules have carbon, right, and hydrogen. Again, carbon and hydrogen, and so on. Carbon, hydrogen, carbon, hydrogen. So we'll talk a little bit more about carbon in a little bit. But just keep in mind that when we're talking about organic molecules, we're talking about molecules that are made of carbon and hydrogen. So, what is the importance of carbon? So we're going to focus on carbon here and why it is that the backbones are all made with a carbon backbone and why is carbon so versatile, right? So carbon is able to bond. If you remember when we talked about valence electron previously, we talked about how we want a shell of 8 valence electron for a atom to be nice and stable and happy, right? So carbon you can see as 1, 2, 3, 4 different valence electrons. Oops, sorry. And so it can bond. In order for it to have a shell of 8 valence electron, it's going to be able to bond with 4 other atoms. And these atoms include itself. So it can actually bond with itself and make either single bond, double bond, or triple bond. So we can see here we have a double bond right here. Oh, sorry. And then we have single bonds right there. And we don't show a picture of triple bonds here, but we can also form triple bonds. You'll also notice that we can actually have a linear where it's all straight, right? So we're just looking at the carbon here when we say linear, right? We're kind of ignoring the hydrogen when we're talking about linear. So we can have linear, we can have a branch where we have 4 carbons here and a branch right there, or we can actually have a ring structure. So that's one of the reasons why carbon is the backbone, is it's so versatile and it has these different features. And keep in mind also, we've talked about polar and nonpolar. These are actually all nonpolar covalent bonds right here between the 2 carbons as well as with hydrogen, meaning there's no electronegative tug, right? Neither carbon or hydrogen is pulling onto that electron more than the other atom. So to actually build these different organic molecules, we're going to use dehydration and hydrolysis. So what do I mean by that? Okay, well, let's start off first by thinking what is monomer versus polymer. So monomers, you can think of are the building blocks. So there are little Lego pieces that we're going to use to actually build like the Lego structure that we're interested in. So each one of these monomers, they have a hydroxyl unit to them, and when you have 2 monomers together, these 2 hydroxyl will actually interact to actually form water. And when they form water, also known as a dehydration synthesis reaction, will actually form the polymer. So what you have happening here is you actually have this guy, this OH and this H combined together, and it actually will form water. And so by forming water, it allows these 2 to actually bind together. And you can see there's another oxygen right there that I can't hit. So now they're bound together. So now we have this monomer and this monomer linking together. So a monomer is a subunit that we use to build larger molecules. And larger molecules are also known as polymer. The polymer are larger molecules that are a chain of a bunch of monomers. And so in order to, for us to use them sometimes, like for example, for us to actually be able to use glucose. So like let's say you're eating a loaf of bread and your body digests it, and that's actually a complex, and we'll see that in a little bit, complex carbohydrate, where your body's going to break that down into simpler subunits of glucose that we can then use to make energy, right? So we're constantly splitting and combining the monomers and the polymers in order to be able to either grow the molecule, make a polymer, or break it down to make monomers. So let's look at these reactions a little bit more in detail. So dehydration, as we said, is the use for synthesis. And so you have monomer 1 and monomer 2 linking their H2O to release water. And in that process, they're able to link together by covalent bond. And so now these two are actually linked together. And opposite, once we have these two linked together, so let's use the example that I mentioned before of the idea that we have bread that we actually want to consume, right? So we want to break down, after we consume it, we want to break it down into simpler molecules for us to use just for energy. So we're actually going to take that polymer, and that polymer is linked together by this covalent bond. We're actually going to add water to it. So we're adding water to it, and when we add water, we actually bring this back. Whoops. Back, and we break it up. So now we have two monomers again. So this is known as hydrolysis. When we are synthesizing and trying to expand a polymer, we're doing dehydration. When we're breaking down, we're doing hydrolysis. So organic molecules, as we mentioned before, are molecules that have the carbon as a backbone, and the carbon is linked to mainly hydrogen, but it also can be combined with many other elements that are covalently bonded to this carbon backbone. And so we're going to talk about 4 different types of organic molecules today. We're going to talk about carbohydrate, lipid, proteins, and nucleic acid.